have your hand nose up and over and have your note packets out, please. Let's go. Have your note packets up and out, please. What page should we leave off on? Oh, and sign into your calculators if you haven't already. What page should we leave off on in our note packet? You can keep them in your clusters. That's fine.
14.
14? All right. 15? Now, last time we had class, we talked about solving out radical equations. By now you should know a couple of things, and hopefully you've made some connections. One of the things that you all need to know is the degree or highest exponent tells you the number of answers that you should be getting. That's number one. Number two, so far we've stopped you every time you've gotten to a position where it's been that you have x squared is equal to some negative number and you're trying to take the square root of a negative number, or you have a negative radicand. Today we're going to go through and work on solving that out. Take a look at the first one up for 1a. We have 5x squared minus 100 is going to be equal to 0. If your task was to solve this out, Vicky, what would you go through and do to start it off?
Add 100 to both sides.
Good, so that means I have 5x squared is equal to 100. What would we do next from here, Peter? Good, so now after I do that, what would I write out? Jason?
You write x squared equals 20.
So that means I'm going to have two answers at this point. I'm going to take the square root of both sides. So now I'm left with x is equal to plus or minus the square root of 20. Hands up, please, if you can tell me what that's going to simplify down to. By now, these are things that we should be automatic with. What's the square root of 20 in simplest radical form? We got 4 or 5 of you? 6? There you go. So x is equal to plus or minus 2 roots of 5. Next one up, we're going to get something interesting that happens. Taking a look at what's there, Sarah L., what would your first step be?
Subtract 2 from both sides.
So what would you write out?
2x squared is equal to -2.
From here, what's your next step going to be, Chloe? So I would get that x squared is equal to -1. From here, I'm going to go through and take the square root of both sides. Up until now, some or all of you have not had a way to solve this. Now, what you have to understand is, in mathematics, when you reach an impasse, you look for a solution. So there is no number that times itself will give you -1, or any negative number. Because when you multiply a positive times a positive, you get out a positive, and a negative times a negative gives you out a positive. So instead, what we have to do is this. We will define the square root of -1 is the number I. And it's an I with a little tail like that, so it's called the imaginary unit. That's something that you need to make sure that you know. So the square root of square root of -1 is equal to I. So now applying that same principle over here, we would say x is equal to plus or minus I, because that's the square root of -1. When we're simplifying down radicals now, you've opened up a whole new set of numbers. You have real numbers, which are numbers like 7 and 11 and 46 and -82 and -7/3. And now you're also able to use imaginary numbers, which are numbers that are going to have an I in them. There's a real component to some numbers and an imaginary component. So sometimes you'll see numbers listed out as 7 plus 2i or something to that effect. Another thing that we'll work with quickly, the imaginary unit, which is I, represents -1. Complex numbers can be written in this form, a plus bi form. And I'm going to ask us to go through and list this out. I can't remember if I put this in here or not. Did not yet. What we're going to do is give out what's called the wheel of I, because you've got to process what's given to you. Because I can be raised to some different powers. It hasn't been yet. We will soon. And we'll start off with I to the 0 power, I to the first power, I to the second power, and I to the third power. You can evaluate out I to the 0 power without a calculator. Hands up, please, if you can tell me what I to the 0 power is going to be. 1. Any number to the 0 power is going to be 1. What's I to the first power? Well, that's going to be an I. Now, here's the part where there's a little bit of logic applied to it. I squared is equal to something squared. What do I get, or what is I equal to? Let's say that. Hands up, please, and tell me. What's I equal to again? So what would I get, Peter, if I took the square root of -1 and then squared it? -1. So I squared is going to give you -1. I to the third is always a bit awkward, so I'm going to do this instead. In order to get I to the third, I'm going to take I squared times I. Because are those equivalent to each other? Yeah. What replacement can I make out of that if I separate it out into a product? The simplification of I to the third should be kind of easy. What can I swap out right now, or what do I know the value of as it's written? 3 of you see it? You literally just did it. I squared is -1, so this is -1 times I, which would be -I. Now, there are times when you will have the calculator to do these and times when you won't. Understand this, and we're going to hit on this later today. So if I ask you what I to the, and another thing that you need to remember, this is cyclical, meaning it goes in cycles, and it's called the wheel of I. You're going to count your way around. So when we do this out, I to the 4th, it starts 0, 1, 2, 3. I to the 4th is going to fall on top of I to the 0 power, which means I to the 4th is the same as I to the 0, which would be a 1. And you can literally get it by counting. But you should be able to notice a short, well, we'll say this. Hands up, please, if you can tell me what I to the 11th power is going to equal. You start at 0, cycle your way around. Hands up, please, if you can tell me what I to the 11th is going to be equal to. I got 1, 2, 3, 4, 5. What do you want to say? -I. Now, there's a bit of a shortcut, and I'll tell you this. When we teach this at U of R, one of the questions on the exam is to go through and evaluate out I to the 403rd power. Now, it's because there's a pattern and we want you to see it, and every year we'll say this. There was, in the spring semester last year, you get 2 hours when you're at college for a test. And so they sit down and they go to take it. Most people are done in an hour. They sit down, they go through and they take the test, and all of a sudden I start hearing this. It was going on for a very long time. It sounded like a chicken getting pecked to death by another chicken. And it was the intellectual equivalent of that. You could actually sit there and peck your way around the wheel of I 403 times. That is not the spirit of the question. That's not the goal. Hands up, please, if you can tell me a little bit of a shortcut that you might see that would allow you to perhaps save. And by the way, I literally had to stay an extra 20 minutes for this person to finish pecking their way around. There are kids sitting there, like, you all don't realize it because you don't see each other during the test. Like, sometimes if somebody coughs a lot, you'll always get the person's like, and this person's not. Now, there was a girl sitting next to this person that's pecking around on their paper, and she leans over and she just goes, and then she uttered an obscenity under her mouth and then under her breath and kept going. And I have to say, I somewhat agree. Because, again, imagine hearing for like 15 minutes. And by the way, they got the question wrong, which was even better. They were off by 1. Who sees the shortcut? Instead of pecking your way around, what would you go through and do? Yeah. Divide it by 4, and whatever the remainder is, that's where you're going to end up. Or you could go through and say, what multiple of 4 is nearby? Now, I give this one because what multiple of 4 is right nearby 403. Hands up, please. There's 2 neighbors that it's got. 400. So I to the 400th is going to land up top. 401, 402, and 403. You could have also used 404 and gone back 1. It doesn't matter. Anything in the ballpark will help you. But every multiple of 4 falls up top. So I to the 403 power is going to be negative I. For the same, and you'll all hear them. Because you have to remember the spirit of the question. We're not asking you to do it 403 times. So let's go through and now we'll start solving with it, taking a look at what's there. Emily B, what would our first step be in solving out number 2? So now I'm left with 3x squared is equal to negative 12. What would I do next from here, Jack? Terrific. And what are you going to have? What would we do next from here? Jonathan? Careful. I heard you say square both sides. Square root both sides. Terrific. Now, once we get to here, this is where it gets awkward. I already know it's going to be plus or minus. Now, what is the square root of 4? Hands up, please, if you can answer that. What's the square root of 4? What do you think the square root of negative 4 would be? What's that? Close. That's the square root of negative 1. No? Who's got a guess as to what they think 2i? You simplify it out exactly the same as you would if it was there. Here's the justification. It's negative 1 times 4. The square root of negative 1 is I, and the square root of 4 is 2. But as you do the question out, you should understand this. The square root of 9 is going to be 3. What's the square root of negative 9 going to be? 3i. The square root of 16 is 4. What's the square root of negative 16 going to be? 4i. The square root of 25 is 5. What's the square root of negative 25 going to be? The square root of 8 is 2 root 2. What's the square root of negative 8 going to be? 2i root 2. The square root of the negative sign is just going to introduce an I. So those are the answers that we would go through and get questions on those. All right, let's bounce forward, please, and let's express these out in terms of I. So looking at what's there, what's the square root of negative 25 going to be, Eli? 5i. And what's the square root of negative 49 going to be? No. What you got? It's going to be square root of negative 49. 7i. Now, do we have like terms that we can put together? Absolutely. Taylor, what are you going to get when you put them together? There you go. What?
Couldn't another solution be negative 2i because it's plus minus 7?
Nope. That's only, you give the principal root. It's only plus or minus when you take the square root. If it's x squared, because remember we talked before, the only time it's plus or minus is when it's x squared equals a value when you take the square root. Looking at what's there, we should be good enough now to start doing these in our head. Hands up, please, if you can tell me what the square root of 8 is going to simplify to. What's the square root of 8 going to simplify to? 2 root 2. So what's the square root of negative 8 going to be? The only difference is that negative sign. What do you want to say? 2i root 2. The only difference is if there's a negative in there, you have an I out front. What's the square root of 18 going to simplify to? Hands up, please, if you can tell me that. The square root of positive 18. 3 root 2, and then negative 18 would be 3i root 2. So now let's go across. Do I have like radicals? Absolutely. So what do I get when I subtract these? Trevor, what do you think?
You get negative 1i root 2.
There you go. Let's do these powers of I without a calculator. What's I squared going to be? Hands up, please, if you can tell me that. Hands up, please, if you can tell me that. I squared, you just filled out that wheel. Think about what it looks like. We got 4 people, 5 of you. Noah, what are you going to say? Negative 1. What about I to the 40th? Emma X, what do you say? Think about that wheel. Where's I to the 40th going to fall? And then that's what it's equivalent to. What's that? There you go. Because it's the same as I to the 0, which is 1. 8i to the 82nd. This, for some reason, is a little bit diabolical too, so let's answer this first question. Haley, what operation is getting done between the 8 and the I to the 82nd power? Multiplication. So now I'm going to ask myself this. This would be 8 times I to the 82nd power. Hands up, please, if you can tell me what I to the 82nd power is. You can reference the wheel of I if you need to, but you shouldn't be going to the calc to figure this out. You need to know what your multiples of 4 are. We got 1, 2, 3 of you, 4, 5. I to the 82nd, what do you want to say? It's going to be a negative 1 because it's equal to I squared, which is negative 1. So this would be negative 1, and your answer would be negative 8. Negative 3 times I to the 266th power. Think about a multiple of 4 that's near 266, and then count around from there. Who can tell me what I to the 266th power is the same as? We've got one person. We need to start pecking our way around. Go through and do it. Although your wrists might get tired of you, and or your neighbors might get tired of you. We got 4 or 5 of you who can tell me. 6. What multiple of 266 is nearby? Or multiple of 4 is nearby, yeah? So you did 260? 264, okay. What's I to the 264th going to give you? So what's I to the 266 going to give you? Yeah. So this would be negative 3 times negative 1, which would be a positive 3. We're going to do the next 2 on your own. These, by the way, when they're given, would be calculator-free questions. Go do 8 and 9. Who got an answer for 8? Terrific. 2 people. Negative I. I'd say that we know I to the 24th is going to be equal to 1. And we go back 1 and get a negative I. This is 12 What's I to the 41st the same as? Hands up, please, if you can tell me.
I.
I. So your answer would be 12 times I, which is just 12I. Questions on that? Go through and do out 10 and 11. Make sure you've signed into your calculators if you haven't yet. Oh, shoot. What did we get I to the 93rd to be the same as? Hands up, please, if you can tell me what I to the 93rd is the same as, Jason?
Negative 8I.
This comes out to be an I, so this would be negative 8I.
Wait, what? Was it necessary to show first?
Well, because I asked first what the I to the 93rd was.
Oh, sorry.
That's all right. Take a look at 11. I to the 501st. Hands up, please, if you can tell me what that's going to give you. Think about what's going to be nearby. It's going to be an I. So this would be 4 times I, which is 4I. Now, we talked about the Cartesian plane before. Now we're going to go through and talk about the Argand plane, which is different than the Cartesian one. There is an imaginary component and a real component to the answers that you're going to be giving. When we list out numbers, the real number is the one without the I attached to it. That's going left and right. The imaginary component is up and down. When you do this out, the most common mistake, and it's when limited people show you how to do it, is that you don't draw it out as a vector from the origin. You don't know what a vector is yet, but I think you know. Do you remember what a ray is from last year? Okay, so it's a vector is a ray in space. So we're going to graph these two values. Here's my real component, and here's your imaginary. When you label your axes, it's x and then yi. This is the x component. This is the yi component. So if I'm graphing this out, I would go to negative 3 on the x. So negative 1, 2, 3. And and the yi piece is just an I. So I go 3 back. And then since it's positive I or 1I, I go here. This would be the point negative 3 plus I. And you draw not a point, but a vector going to it, which is an arrow from the origin out to that point, ending at that point. Who can tell me which quadrant 2 minus 5I is going to get plotted in? Who can tell me which quadrant 2 minus 5I is going to get plotted in? We've got 3 people, 4. Which of our quadrants? Courtney, what do you think? Terrific. Over 2, down 1, 2, 3, 4, 5. Put a dot there. This would be 2 minus 5I. And to sketch it, I put the point there, draw the arrow coming out, the vector, ending at that specific value. Questions on that? We're going to express these out in simplest A plus BI form. Now, this is the part where you're going to have to piggyback and make sure you know your exponent rules, number 1, and that you're not afraid of algebra. Because some of you, again, start panicking when the numbers get slightly large. Taking a look at what's there, I start off, this needs to get handled first. And it's 3 products. So it's this times 3I to the 81st and times negative 2I. Now I'm going to go through, I need to take 5I to the 7th. That means you need to take 5 to the 7th and I to the 1st, then to the 7th. What's 5 to the 7th power going to be? I don't know, but you all have calculators. Go in and evaluate it out. Hands up, please, when you can tell me what that's going to give you. We got 2 so far. Thank you. 3 of you. Thank you. What's 5 to the 7th going to be?
78,125.
Now, I get to here. There's components that are going to simplify. What components are going to simplify? Well, I to the 7th and I to the 81st. Actually, you know what we can do? Let's do this, because this will help condense everything down so you're only simplifying once. Remember, if it's not written in the powers of 1, let's multiply going across. What do I get if I multiply my coefficients? There's 3 coefficients here. Go into your calculator if you need it. Hands up, please, when you can tell me what you get from multiplying those 3 coefficients going across. We've got 3 people, seriously, 4, that can multiply. I couldn't hear the last part. 750?
Yeah.
Okay. And now we need to figure out times I to this power. Does anyone recall what we have to do to multiply these i's, or when we multiply these i's together? What do we do? You add, what do you say by them? Add the exponents. So I've got to take 7 plus 81 plus 1. Hands up, please, if you can tell me what that sum is going to be. 88? No? Don't forget, this has got a 1 on it.
Oh, yeah.
89. Now, go through. Hands up, please, when you can tell me what I to the 89th power is going to simplify down to be. What's I to the 89th power going to simplify down to be? Think about the wheel of I. Every multiple of 4 shows up top. It's going to be a positive I, because what would be right up top, or what multiple of 4 did you use? Yeah. You could get 88, and then 1 more gives us that. So this would be negative 468, 750 times I, and that doesn't simplify down anymore. So, questions on that? Notice those were multiplied together, so we could do it all at once. For 14, it's not all multiplied together, so we need to simplify out these individual i's first. So, in your groupings right now, I need you to tell me what each of these individual i's, you cannot add them going across because they are not multiplied together. What would you get for each of those individual i's going across? Go through right now and evaluate out those 4.
The answer is
Evaluate them out, because it's going to be 7 times something. Who can tell me, please, what I to the 488th power is going to be? Did you get it? What's that? 1, all right. Who can tell me what I to the 113th power is going to be? Did we get anybody that got that one? Go ahead. Positive I, all right. What about 227? Where's that going to go to? What's that? Is that 1? I thought I got it to be, what did you get? Yeah, I thought it came out to be a negative I. What about I to the 18th power? I didn't get that to be 1 either. Negative 1, yeah. So now let's simplify this down. Look at how nice this is. 7 times 1 is 7, minus 3 times I is negative 3i. 5 times negative I is minus 5i, and over here, negative 6 times negative 1 is plus 6. Let's put our like terms together, and now we have 13 minus 8i. You would easily be expected to do that on an assessment or a test. One thing I'm going to add on there now is this. Your homework is on the next page, and we'll show you what the answers are before you go. But I do want to show you this, so everybody make sure that you're in your calculators and that everyone's gone through and logged in. So, when we do these questions out, on the Regents exam, and for checking purposes, this works, because some of you are going to be shocked on tests that we get later on, where you're allowed to use the calculator, but if you go through and use the calculator to its fullest capacity, and you don't show out any knowledge, you're not going to be getting it right. Go into your calculators right now, and let's do the first piece, which was 7 times I to the 483rd power. So go in and hit 7 times. Now, hit Control and then pi. There's the I button. Select that. And it's I caret and whatever power we had in that last question. It was 483 or something like that. 480? 488. 488, sorry, 488. So change it to 488 and hit enter. Now, this is the stuff we went over it the other day. This garbage with guess and check is not viable math. It doesn't earn you points under any circumstances except on the Regents exam because, again, they're trying to herd all of the sheep through the gate. What you have to understand is the calculator is a great tool for you to check your answer, but not to arrive at it. Because on your tests and quizzes, understand that there will be times that the calculator is taken away from you. If you can't evaluate that out without using the calculator, you're not going to be able to be successful. That's why we're never going to be using that as our primary means of getting an answer. Now, type in the whole expression, please. And by the way, here's one to do too. If you ever forget, type in I to the 0 power. And you can't use the I here. It has to be from the pi button. So let's evaluate out I to the 0 power. So Control pi I to the 0. What's that going to give you? 1. You always can use it to even construct the wheel of I if you don't remember it, and it's on some section where the calculator is permitted. Go in and do I to the first, I to the second, I to the third. Do you see how all of these are starting to come out now? And I'm going to tell you this. This is one way also that some people remember. I'll show you this and then we'll go back to the calculator one. Here is one way that people remember what the wheel of I is going to look like. It's almost like a compass. What do you notice about the outputs going north and south? Tyler? Yeah, and they're opposites of each other. What do we notice about the ones going east and west? They're I's as well. One's negative and one's positive. So if you remember it goes 1 and then I, then you should remember the next two. Go in, please, into your calculators and fully input the last question that I gave you as it looks, so 7I to that power and so on. Is that what we got? Is this what our answer was? Yeah. So when we tell you that you're smarter than plastic, that's the stuff we're talking about. How long did it take you to type that in? A really long time. A really long time. Steve? Then go to menu, or sorry, go to the home screen, go to like settings, and maybe document settings. No, degree doesn't close it. Oh, you're in polar, not real. Now, we're going to have you do, your homework is on the computer. What we're going to do is this. All right, you should be good now. All right, what we're going to have you all do is this. I'm going to have some of the groups stand back, but you've got about 10 minutes. Have your books, your computer books out, and get started, please, on the homework questions together. Work with your group. I'm going to give some of the group members papers to hand back, because you guys have a ton of papers to go back.
So wonderful.
Hand these back. Don't hand these back, please. And these back.
I'm so excited to see my grade.
Good. Here you go.
Oh my God.
Probably now I can go down. Okay?
Oh, Matt, I wonder.